Hello everybody. Today is day 18th of Advent of Code puzzle challenge, and today's puzzle is called Ram Run. So you and the historians are somewhere inside of the computer, and over here there is some memory stuff, and it's not safe to be over there. So you're in some kind of RAM, in memory RAM, and some memory spaces are falling down, and you need to get out of there. You're in some kind of RAM element and you need to get to the other side, but all the time the RAM elements are keep falling to you. So they fall in every nanosecond, but you are faster than that. And what you do is that you have a grid. So in real data, it's from 0 to 70, but in the example input, it's from 0 to 6. And here are the locations that pieces of memory is falling. And so yes, so that each byte position is given by x and y coordinate. And you and the historians are currently in top left corner, and you need to exit to the bottom right corner. Yes, so in small example it is smaller, but in your example it's 70 and 17. And you need to simulate falling pieces. And what it is in the example is that if 12 bytes have been fallen, then the map looks like this, and you need to check how many spots you need to get out from here. How many places you can take to get out of from here. And in real data, you have to simulate if you have 1024 bytes. So this is kind of just a regular Dijkstra problem, and let's try to do it. So I have everything set up over here. So maybe for the test data, let's put x length equals 0 and bytes are 12. But then maybe if you are going to get the real data, then let's say the x length is 2024 and the bytes are 1024. Wait, the x length is 17. And we can also actually say that it's just the length, like that. And first we can comment out the real data things. Yeah, and now what we can do, we can initialize some grids. So we can initialize the grid where the data has been holding, and then we can also initialize this kind of checker grid. So I will initialize two grids. First is grid and the second one is data grid. And let's just, for the grid, let's just put everything as a dot. Yeah, everything as a dot, and how it is. Dot for y in range. Let's see, length. I don't like this length. Let it be length x. And another thing to see over here, that it's actually, if it says that it is 6 bytes long, then if you read it, then over here in the data it's actually seven dots. So so we have to put one over here as well, and then for j in range, length x plus 1, like that. I think it works like that. How it goes, like that. And also let's do the same thing for the data grid that holds the values, so we can count them. And over here I just put some other variable, like that. And now let's get all the data inside there. So it says some kind of we only need to take the bytes that had took so let's give some counter over here, and then for k in open input.txt, let's show that k, the x and y are k dot strip dot split. Let's split them by comma, and then let's add it somehow. Create. So what it is? Integer of y. Let's put them other way around. Integer x. Let's mark it somewhat else. So in the example they are marked with asterisk or with hashtag. So let's mark it the same way. And we also have to increase the counter, and if counter bigger or equal to bytes, then let's just break. We don't need to check anything else. In the part 1 we just needed to check what happened with the bytes that we had over there. All right, let's just see what it is. For k in create, print that join k. Let's see how our program looks like. Let's see how our create element looks like. If we get the same example as it is in the example program, then it's good. Now what happened over here? Index out of range. What it is? X and Y. Create. What is the create? What is the create? Let's see. Create. So what did I do now? Yes. So over here, and this one goes here. I initialized the create a little bit wrongly, like this. I still get an error. Yes. Right, double braces in the front, and then you have to put the into the other way. All right, what it is? So it's almost works, but if you have 12 bytes, then you can see that this element should not go over here. So this is not a valid. Maybe I will just put the counter in front like that. So maybe we can just. So this is just like a -1 error, but okay, all right. I like the create, and now we can start to work with it. We need to get some Dijkstra algorithm over here. Okay, so the data create, we can say that since we start from the 0th position, then we can say data create 0 and 0 is 0. And also, let's see some current elements. Let it be that only we have 0th element over here. And now let's do some while loop. While true. Now it is that for element in, I want to have a copy element, and so for that is that copy element equals cur elements, and the cur elements equals empty array. In order to do that, I know that the copying array, it's somehow it copies its registers, the registers values. So we need to use the deep copy thing. So for that, we can do import copy. And over here, let's put copy that deep copy current elements. And yeah, current element. And then we check that current elements will be the 0. And over here in this method, we add something to the current elements. So let's see let's put some, I don't know, one variable as well. So we will check all the neighboring parts now, up, down, left, and right. So we need to check in 4 positions. So let it be some check elements. So we need to create this method, and we need to have some counter as well. Some counter equals 0, and let's put counter plus equal 1. Check elements. So here is up, right, down, and left. So up is y. Wait, let's call it y and x. They will be. I would like to do that the y element is first in the input data. The x element was first, but I like it if the y element is first. So let's say that it is element 0 and element 1. So here is y minus 1 and then x. And let's put the count as well. Maybe it's useful to have a count as well over there as well. All right. So for neighboring places, 5 plus 1 and x minus 1. Yes. Now we have to do the check elements. Let's create this method def check elements. So it gets y, x, and count. First thing we need to check is that if it's out of bounds, we don't want to get any index problems. So how it is? If 0 y and length of x and 0 x and length of x. So that length of x and y creator is all the same. So it we don't need to put the y length. But I think I do think that we need to insert it to this method. So let's say global length of x global. So now in this method, what we need to check if what it is, if create y x equal like that, and also we need to check that if data create y and x equal data create we initialize it with x. Then what we will do is that data create y and x equals count, and also cur elements dot append y and x, like that. And also we can somehow we should return something. So let's just return 0 if it's just like the normal place to be. But then let's do that as well. If y equal length of x and x equal length of x, then we will return count. All right, like that. And then now if you return the count, so this so all the time it returns 0, but if it returns the count, then we're almost finished. So yeah, I will do that if result not equal 0, then we can do print found, and then let's see count, and let's also do break. And also if we have if length of cur elements equal 0, then raise exception, so that it shouldn't get over here. So all right, maybe it works, maybe it doesn't work. Let's see, let's start to debug it. Did we got so what it is, currently I have the test data. So if I get 22 steps, found 22 steps, very good, very good. We can also put on the real data here. Yes, let's put on the real data, and also let's take the real data length. All right, let's do it one more time. Yeah, so with the real data, my answer was 246. Do I get the same? 246, yes. All right. So the part 1 is finished. Now for the part 2, the part 2 was quite at the same. It was just that you needed to check how many more stuff you can put to the grid in order to find it. I think I will skip it over here, but yeah, the part 2 was quite similar. It was not that that hard actually. So you how I did it, it was that I first made some list elements, and I put them all. So I put everything to the grid, and then I started to take them out one by one. So yeah, how the part 2 went. It went pretty good. At first time it took a little bit more time, but when I started to do it from the upside down, so that first you initialize the grid with all the values, and then one by one you check if you can reach to the end. If you cannot reach to the end, then just one by one you start to remove the elements from the end of the grid. So yeah, that was the solution. Today's one was a little bit simpler one. Yesterday and day before they were a little bit too difficult, so it was a little more to struggle. But yeah, today was a little better. So it took me 50 minutes to solve the first and the second part. So yeah, pretty pretty good. But yeah, the yesterday's time was that it took me 4 hours, and I still got some kind of the rank 3000. But today's thing that I finished it with 15 minutes, and I got the same rank. So today's puzzle was a lot more easier than the yesterday's puzzle. So yeah, I will leave it over here. So yeah, see you.